Hi everyone, I am Erkelinus Namya together with my groupmates Roger Regalado and John Joshua Borak, and welcome to our presentation. In this project, we explore three important algorithm concepts in computer science: the NP-completeness, approximations algorithm, and randomized algorithm. These ideas help us solve complex real-world problems where exact solutions are too slow or hard to find. We'll explain each concept in simple terms, give real-life examples, and show how they work using Python code. Let's dive into how algorithms make everyday tasks faster and smarter.
Hello everyone, my name is Roger Irigalado and today I will be the one who will explain the real life problem and proposed solution of approximation algorithm. So first, let us know what is approximation algorithm. So an approximation algorithm is a strategy used to find near optimal solutions to complex problems where finding the exact solution would take too long. So these algorithms are useful for NP-hard problems and offer guarantees on how close the result is to the best possible answer. So they're practical when we need good enough answers fast. So let's come now to the real life problem of approximation algorithm. So the real life problem in approximation algorithm we choose is about the vehicle routing for delivery trucks. So in logistics, determining the shortest path for multiple delivery trucks to serve multiple clients is a variant of the NP hard capacitated vehicle routing problem, or the CVRP. So as we can see here, we have our code which is in our proposed solution. So this code deals with a simplified version of the vehicle routing problem, having delivery truck while showing similarities to the well-known NP hard traveling salesman problem. So the vehicle routing problem requires computational resources that are not available for delivering multiple stops. So real-time logistic systems use greedy nearest neighbor approximation algorithms for quick practical solutions. So first, we will have a code walkthrough. So let's go in this part of the code, which is calculates the distance between the 2 points on a 2D plane. It uses the Pythagorean theorem, or the Pythagorean theorem, to measure how far apart two locations are. Next is this part of the code, which we define the greedy VRP function. It starts at a depot, copies the list of customers, and begins at the depot location. Next one is this part of the code, which is where the greedy approach happens, and the truck always goes to the nearest unvisited customer. That customer is added to the route removed from the unvisited list and becomes the new current location. And finally, this part of the code, which is after visiting all the customers, the truck returns to the depot. So here's how we run the code. So as we can see here, the output of the code is this line. You can see here the deliver route. Uh, so let's break down the output. The truck starts at the depot, which is at, you can see here the 00. Then it visits the nearest customers at 1 and 2, then followed by 2 1, then 4 3, and 6 2, and finally returns to the depot. This route is not guaranteed to be optimal, but it's computed very quickly and is good enough for real-time delivery systems where time matters more than perfections. So this kind of algorithm is used in logistics software to generate fast delivery plans for companies like Amazon, FedEx, and food delivery apps. The speed of decision making is critical, especially when handling thousands of deliveries. That's all, and thank you.
Randomized algorithm. A randomized algorithm use a random numbers during its process to make decisions. This randomness can lead to a faster or simpler solution, and sometimes it's used to avoid worst case scenarios. There are two types. Las Vegas always correct a time varies, and Monte Carlo, it's a time fix. Result may be incorrect with a small probability. So we have a real life problem. A real life problem is a load balancing in a web servers. When we request arrive unpredictably at a different times, using a randomized approach can help distribute tasks fairly across multiple servers. So we have here proposed solutions that we can apply. So we have here a code. So the first line is we need to import the random, and then next is we need to code the function to assign incoming web request to a random service servers, and we define the assignment request servers and the num request. So assignment is equals to s for s in the servers. It's initiate a request count per server. So we have here the for in range the num request, and it will select the random choice the servers. It will randomly select the server, and the assignment selected is equals to plus equals to 1. It is assigned the request, and it will now return the assignment. So next is the example usage. The servers is equals to server 1, server 2, and server 3. This is the list of available servers. And the num request is equals to 1000. It's a total incoming request to the distributed. And the last is the we need to run the algorithms, and we have here the result is equals to assign request, the servers, and the num request. And the last one is the print request algorithm result. So after this we code and we run the program. The result will be request assignment is equals to server 1 361, and server 2 is a 323, the server 3 is a 316. So the program presents basic but efficient algorithm through randomized to tackle the web server load balancing problem. To prevent system inefficiencies, high traffic system must evenly distribute their unpredictable incoming requests across multiple servers to avoid server overload. The algorithm implements random dot choice from a Python to randomly distribute each incoming request among available servers for each 1000 entries. So additionally track servers assignment by using server name as key that correspond to the request, handling count as value. The random selection method helps obtain balanced distributions among servers since it diminishes the probability of saturating any particular server. So I already said the output. The listed outputs indicate the server 1 hanggang sa server 3. This distribution method provides close enough balance between a server request to maintain system efficiency for CDN and cloud platform application.